Hello everyone, and welcome back to our series on bioprinting. Today we're going to be talking about support substrates, and specifically we're going to be making an agar slurry to help support our prints as we are extruding them from our syringes. So I'm going to be making a agar solution. I'm actually not going to make the whole solution here today, but I'll show you the process of going through that and talk about some of the aspects of that. And then we'll take the agar and then turn that into a slurry, which you can use to support our prints. So to make the agar solution, I'm going to make an example of just 100 milliliters. Let me get my scale turned on, open up my distilled water, place my beaker on top of my scale, zero the scale, and I'm going to try and pour out 100 milliliters of water into this jar. And then to that, I'm going to add 1 gram of my agar powder to make a 1% solution. A little more than I wanted, but again, we're going to write down that value and we can calculate the actual percentages as part of our experimentation. Then I also want to add 0.1 grams of calcium chloride. Now, rather than adding in 0.1 grams directly, what I did is I actually pre-made a 1% solution of calcium chloride, and then I can add 10 grams of this to 100 grams of my solution to dilute that and have it end up being a 0.1%. So now I've got my agar and my calcium chloride mixed together in this solution, and I'm actually going to have to heat this up for it to form into the gel that I want. So I'm actually going to try and bring this to a boil. I'm not going to do that here because I don't want to make a mess. Do be careful when you're boiling this solution. It will want to bubble up and boil over as it reaches that hard boil point. You'll also notice that when it comes to a boil, right after it's done boiling, the haziness of this solution, the agar powder in the water, will go away. After that comes to a boil, I can put that in the fridge to let it set and cool down, and then after it's set, it's going to look like this, where it gets hazy again and becomes almost kind of a milkish, somewhat opaque solution. On this, a few things that I'll note rather quickly is that the reason I want to have this is if I take my calcium chloride, like in our second activity, and I try to extrude my alginate into that, it's going to want to try and follow the needle as it extrudes. It won't stay in the same space. So if I try and extrude, you see it a little better. You see how the alginate is kind of stuck to the tip of my needle and gets dragged around with that extrusion. So that doesn't allow us to deposit the alginate where we want it because it's going to try and stay with that set. I'm trying to make sure I get all the calcium chloride out of my needle before I leave that to the side. The other thing is if I take something that's somewhat solid like this pure agar and I try and extrude through it, what's going to happen is it's going to tear kind of slits in my solid, and then rather than staying at the tip of the needle, it's going to slide up these cracks in the agar solution and not, again, form the geometry that we're trying to actually print out. So what we're going to do is we're going to pulverize this gel to make it into little tiny beads, and that'll give us enough resistance to movement of the needle that the streams of alginate will stay where we put them without being so solid that it actually forms fissures that then get backfilled with the alginate as we go through. So let's take a look and see how that works out. I'm going to take my cured agar solution. I'm just going to detach it from the wall of my container so it doesn't have a suction cup effect anymore. And then try and just dump this into a jar. And you can see that is fairly solid. And then I want to pulverize this into a slurry. So here I have an immersion blender, although you can do this with a regular blender as well. And all I'm going to do is I'm going to take some time to pulverize this into a fine slurry. You can't really over blend this, but you can under blend it. So make sure you get all of the particles or the chunks of the agar blended until you get a fairly smooth consistency, and now you've got very small chunks that will flow easily around your needles as you're extruding them. I'm going to take some of this and I'm actually going to add a little bit of liquid calcium chloride diluted, again down to that 1:10 ratio, so I have a lower concentration, so that way I can make a little bit of a looser concentration. We can see that this is actually still fairly stable, and that will help the particles flow just a little bit better. Actually, I want 10 milliliters total, so I'm actually add 9 millimeters of still water and 1 milliliter of my 1% to make a 0.1% concentration. So that's my 9 milliliters of distilled water. We'll add 1 milliliter. We overshot just a tiny bit. So really we've got more like, that was 1.3 milliliters, so 0.13% calcium chloride in that solution. So I'm going to add to this 9 more parts of my mixed agar slurry. So we'll fill that up until we get to 100 milliliters, which will be most of this. This is started off as 200 milliliters when I mixed it, and then it boiled down to about 180 milliliters total. Then I lost some to the blender as well. So you do want to make sure you make more of this than you think you're going to need, because it's hard to get it out of the jars as you're mixing them. Let's get right up to 100. There we go, that's pretty good. And I'm going to mix this. The other advantage of having a little bit of that fluid inside of this is going to help me get some of those bubbles out. So I'm just going to mix that, and you can see it's a little bit more flowy now that we've got some of that water added to it, and we can tap it down, try and get some of those bubbles out. Now let's see how this works for our extrusion process. I've got one of my, this is a 4% sodium alginate from one of my previous experiments. And again, if you've got these laying around, you save those, good for using on subsequent tests as you're setting up your system. So I'm going to try and get this so you can see. You can see I actually extruded that out at a fairly specific depth, and if you look at it from the top, you can see I have a ring there. I can draw various shapes, and they will keep the geometry that they had as I extrude them in this slurry. And do a little bit more so you can maybe see it a little bit better from the side, or bring in some different lighting. Hopefully see that that is staying at the depth that I'm extruding it to. Try and get a little more in there. You can see it's all at I'm going to do this by hand, so relatively the same depth. And the shape is staying fairly consistent. We combine this with the accuracy of our bioprinting system, we should be able to get fairly complicated geometries printed out with a reasonable amount of accuracy. Hope you enjoyed the video. Thanks for watching.